Good day everyone, I'm John Francis Evangelista from Z1F and I'm here to have or create a video tutorial about measures of variability. Let's begin. The table below represents the teacher's ages in mataas na kahoy. Let's assume that this comprises the whole population. Find the interquartile range, the quartile deviation, the MAD, the variance, the standard deviation, and range. So our given here is the ages and the frequency of the ages. So first we need to get the class width. Simply, it is 29 minus 24, or the lower boundary minus the lower boundary of the preceding value. So 24 minus 29 is equal to, or 29 minus 24 is equal to 5. So our class width is equal to 5. Then we need to find the cumulative frequency of this value. So first, we need to rewrite this, the first term, and then this first term will be added into the second term. 10, and then add another term, 20, and then plus 11, 31. Remember this, that the cumulative frequency always equal to the number of observations in the end. Therefore, this x represents the class mark. So how can we get the class mark? It is the mean of these two values, or our h bracket. So simply 28 plus 24, 28 plus 24 divided by 2. So it's 26. Here. And let me tell you a shortcut about this. We can get the next class mark by simply adding the first value by our class width. So 26 plus 5, 31. 31 plus 5 is 36, and 36 plus 5 is 41. So that is our class mark. So we need to get the frequency times the class mark because we need it into our mean, because mean is equal to summation of fx over the observation n. So 5 times 26, 130. Then 31 times 5, 155. 36 times 10 is 316. And then 41 times 11 is 451. So did you get it? That we only multiply the f and x here, and we need the summation of this f. So 130 plus 155 plus 316 plus 451. So it's 1096. So we can get now our mean. 1096 over 31, our number of observations. So mean is equal to, our mean is equal to 1096 over 31 divided by 30. So our mean is 35.35. So why do we get the mean? Because we need it here. We need to subtract the class mark to mean, or x minus to mean. So 26 minus 35.35. Because we apply the absolute value, or we need to get the absolute value, we disregard to the negative sign. So 9.35. So again, 31 minus 35.35. 4.35. So the next one, 36 minus 35.35 is 0.65. And the last one is 41. This is 41. 41 minus 35.35. 5.65. It's 5. So we need again to multiply this absolute value of x minus mean to our frequency or RF. So 5 times 9.35, 46.75. 4.35 times 5 again, 21.75. 0.65 times 10, 6.5, and 5.65 times 11, 62.15. So this table is different from this because we need to square it first before we times it to our f. F times x minus mean squared. So we need to square it first, ha? Always remember that. Maraming namamali dyan. 9.35 squared times the f, the 5. 437.11. So next one is 4.35 squared times 5 again because it is 5. 24.61. Therefore 0.65 squared times 10. 1.22. Then 5.65 squared times 11. 351.15. So we need the summation of this, and we will use it later. 437.11 plus 94.61 plus 4.22 plus 351.15. 887.1. So our lower boundaries is simply the lower boundary here minus 0.5. 24 minus 0.5. 23.5. And then apply it also in this next lower boundaries. So 29 minus 0.5 is 28.5. 34 minus 0.5 is 33.5. Then another is 38.5. So we fill every data in our table here. So we need now to compute measures of our variation. So we need first to compute the simplest variation, the range. So highest boundary minus lowest boundary. So how do we get the highest boundary? So this is our highest value here. We need to plus it with 0.5. So 43.5. 43.5 minus our lowest value here minus 0.5. So it is 22.5. Equals 20. Therefore, our range is equal to 20. So, next one is we need to compute for our interquartile range. So first, we need to compute the Q1 or the quartile 1 with the formula of the lower boundary of the quartile class n, or the observation here, over 4 minus the cumulative frequency before, or the lesser cumulative frequency before the cumulative frequency of the quartile class times V. So first, we need to to find where is the quartile 1 class. So n, we can get that n over 4 with the n over 4. Our n is 31 over 4. 31 divided by 4, 7.75. So we will get this 7.75. We will mark it here in our cumulative frequency. So, is it in the 5? No. 10. Yes. 7.75 is included in our 10. So this is our quartile 1 class. Here. So we need to get this quartile 1 class. We need to get the lower boundary. So 28.5 here. 28.5 plus 7.75 minus the cumulative frequency before the cumulative frequency of our quartile 1 class, so minus 5 over the frequency of our class, 5 divided by 5 times 5. So 7.75 minus 5 divided by 5 times 5 is 2.75. 28.5 plus 2.75. 31.25. So our quartile 1 is equal to 31.25. So we need to find the quartile 3 next. It's the same formula, but different here. 3n over 4 minus the cumulative frequency before over the frequency of the quartile 3 class times the width. Sorry, my talk. So we need to find first again where is the quartile 3 class. So 3 times 31 over 4. 3 times 31 divided by 4, 23.25. So this is, we need to find where is 23 over 0.25 included here in our cumulative frequency. So it's not in 20 because it's lower than our cumulative frequency. It's here. In 31. Here. 31. So we need to find the lower boundary. We go to 38.5 plus 23.25 minus the cumulative frequency above 20. And 20 over the frequency of our class 11 times the class 5. 23.25 minus 20 divided by 11 times 5. So 38.5 plus 1.47, you can write it 38.5. 39.98. So we have now the quartile 3, 39.98. So we can compute now for our interquartile deviation or interquartile range. Interquartile range is equal to Q3 minus Q1. So have here the Q3. 39.98 minus 31.25. 8.72. So we can compute now our quartile deviation, which is divided it by 2. So Q3 minus Q1 over 2. So it is 8.73 divided by 2. 4.36. That's how we get the interquartile range and our quartile division. So lastly, we need to compute for mean average deviation, our variance, and standard deviation. So the formula here is the summation of f times the x minus mean absolute value over n. 46.75 plus 21.25 plus 6.5 plus 6.5 62. 137.15. So, summation of f x to 5 over n. So 137.15 over 31. 4.42. So this is our mean absolute deviation. Then variance is equal to, so we always get the sample variance with the formula of summation of f times x minus mean squared over n minus 1. If you want to get the population variance, we need to disregard the n minus 1 and make it n, not n minus 1. So our summation here is 887.1 over 31 minus 1, n minus 1. So 887.1 divided by 30. 29. So our population variance, our sample variance is 29.57. And our standard deviation is simply the square root of our variance. This is our variance. So, square root of 29.57. And that's how we compute it. Thank you.